thank you very much for being here today. I've got quite a lot to actually cover, so I'm going to kind of go through this fairly quickly, but one of the things I want to point out is that we have a second session this afternoon that I would love to have you come by for that and ask the questions when we get to it. But to start the introduction, I have never really spent a lot of time in Alaska, though I was there last week. I spent the last 3.5 days down in Honduras at a conference where we actually communicated entirely in Spanish. So if I lock up here, it's because I've gone into Spanish and I'm trying to figure out the right word. I'll be back with you in just a second if that happens. But also want to thank Ambassador Kaupe for her remarks today. In fact, there were a few things that resonated as she was talking, in that I was fortunate enough to see the Northern Lights as well, but I got to see them from a slightly different perspective, from above, which is a pretty remarkable view to be treasured forever. Also, I've seen the White Nights, but saw those in Russia, which is also an interesting perspective. And then, as she mentioned, she grew up with the mosquitoes, and I've also got an opportunity to experience those up on the North Slope. But I'm pretty sure they were Finnish mosquitoes because they seem to be very happy for most of the time. So what I'm going to do today, though, is I'm going to talk a little bit about what we do in Alaska in terms of the U.S. Geological Survey, and admittedly, I'm going to have to hit this pretty fast. I've only got 15 minutes, so I'm going to be stepping through this pretty quick, and if I go over, the countdown clock is going to tell me that I've gone over. I've seen one of these before, by the way, but there was a much more dynamic ending to the one that I've seen previously than what we're doing. But everything you see on this chart right here are things that we do. Energy resources is a big piece of it. Now, we'll talk a little bit about that. Critical minerals, earthquake hazards, tsunami hazards, volcano hazards, coastal hazards, wildfire hazards, water resources, permafrost change, and the Alaska mapping. And we're going to talk about how that ties all of that other stuff together here in a minute. And then I'm going to finish with a very brief description of where we're going in the USGS in terms of 21st century, because we're sort of at a cusp of how we're approaching science. And science is going to become a lot more flexible, and it's going to become a lot more customer focused. And then we're going to talk very briefly about that at the end. In energy resources, of course, Alaska has some of the largest petroleum resources in the United States, and one of our jobs is to do the analysis on what the undiscovered reserves might be in the country. And so we've had people in the field in the North Slope now for the past 3 seasons. In fact, they're going back up again this year. I had the opportunity to visit with them this last summer. I'm planning on going up to visit one more time. And as you see up here, there's the NPRA, federal lands, and then we have ANWR, which is protected area, the 1002, which is federal lands, and then we have in between is the sort of tan-colored land, that's the state lands. And so we have pretty much all the federal and state representatives here in terms of the area that we assess. That dotted line that you see down on the bottom then there in blue in the center map is that's the forward margin of the Brooks Range. So essentially all of the North Slope is north of there, and you really don't appreciate the scale of this place until you're up there. It's a huge amount of land in terms of what's available to us. Other pieces of other efforts that we're working on are the critical minerals. Now, one of the things that we're dealing with here is trying to do a cooperative agreements with all of our states to help define where are these 35 critical minerals, and those include everything from rare earths to the noble metals. And of course, the only reason that we really care about that is because every single one of us has to have, from the time we're born, one of these, right? So every kid has got one of these. In fact, it's pretty rare to actually see somebody that doesn't have one. I've only been in one place where I didn't get 100% response when I asked the kids who has one of these. And so I've generally started now to asking the question, who doesn't have one of these things? And it's usually only 1 or 2 hands go up, except in one school that I visited in the Northeast, where their parents had all gotten together and said, we're not going to give anybody any cell phones. However, identifying where these things are located are critical to us, and so we have cooperative ventures with our states. In addition, we also mentioned that long list of hazards. And the first one, of course, here is one that was recent to this year, or this last year. In 2018, we had an earthquake, as you know, here in Anchorage. And the images that you see in the center on the right, that's from the 1964 Great Alaskan Quake, which was magnitude 9.2. The image right below it on the lower right is one from the 2018 quake where we had some mass failures along the roads. Apparently it's, the failure surfaces are associated with fill that is out in the front of that house that was used to help stabilize the slope and build out the land. So characterizing these risks are both not only just the recognition of the earthquake terrain itself, but also what's the lithology, the slope stability, the water content, a number of other geotechnical pieces of information that we have to help describe that. One of the great things about it, of course, in the 1964 quake, we had significant casualties and we had virtually nothing and almost no real damage. I was there last week and it's really hard to find any damage from the 2018 quake in Anchorage. Tsunami hazards are also another big one here in Alaska. One of the largest mega tsunamis that's ever been recorded was one that was recorded in 1958 in the Lituya Bay region, where a rock failure after a magnitude 9.2 quake occurred, dropped into the Gilbert Inlet, generated a wave that was over 1,700 feet tall down the inlet itself. So characterizing that is critical to us, and characterizing that is also tied, of course, to our earthquake hazards. But in the upper right, it also ties us in with NOAA. And so one of the themes you're going to get out of all this is there's a lot of collaboration in the USGS with all of our different federal and state partners. And so our characterization is the earthquake piece. It goes to NOAA's Tsunami Warning Center piece. They have about 45 minutes. They have to get the information out so that we can help the rest of the world avoid Banda Aceh, where we lost 200,000 people, as you know. Volcano hazards are critical here in the state of Washington, Oregon, California, and of course in Alaska. Now we don't have a great number of active volcanoes in the U.S., but we do have some explosive volcanoes here in the U.S., as you know. One of the hazards is what you see in the middle image there, and that's the ash cloud. There are direct hazards to the population, as we have here in Seattle, with the volcanic eruptions themselves, also as we saw in Kilauea this last year. But some of the even more critical ones is the ash distribution, which can shut down air commerce and can do it for days, if not weeks. In fact, my wife and I were experiencing that back in 2010. We were supposed to get married in Scotland, and as a sign that God meant it to happen, the Iceland volcano quit erupting for a couple of days. We flew through it, going over, got married. Iceland volcano erupted again, shut down in time for us to come home. So we figured that's a sign from God that we were supposed to be married. And so far, it's worked out. So that's a good thing. Coastal hazards, and this is one that's near and dear to particularly the communities on the north slope, on the north shore, the Chukchi and Beaufort Seas. Some of the most rapid coastal losses in the country, if not the world, are actually occurring here in Alaska. Why? It's a complex set of variables, and our job is to try to figure out what are those variables and what are the key ones. And so those are some of the things that we're working on right now. As of last week, the number that I heard in Alaska was about 32 different communities that are currently at risk or in danger of being affected by this coastal erosion. So a part of our work is to figure out how this is occurring and try to figure out what, if anything, can be done to mitigate it at this point. Wildfires, as the ambassador mentioned, it's not one of those things that most people would characterize in the lower 48 as being a big hazard in Alaska, but it is in the Arctic, as it is everywhere. One of the big challenges, of course, in Alaska is that a lot of the area where these fires occur are remote. And so a lot of how we will address these is, one, a characterization of the risk factors, and that's the environment that the trees are within. But the second is, how do we see them? And that's actually where our Civil Applications Committee piece, which is all about things in space, and we'll talk more about that later. And things in space can see these fires, and first alerts actually come out of some of the work that we do in the USGS. Water resources is a critical component everywhere, and it just depends. I grew up in the West, and so water resources in the West is a critical resource for almost everything, as not only for the humans, but also for the ecosystems itself. Characterizing the water is one of our big challenges. It's actually fairly easy down in the lower 48 in comparison to Alaska, and you'll see that if you get up on the north slope. We can see the rivers. The Kuparuk, for example, is very easy to see and to measure the flow in it. But if you've ever stepped out on top of the tundra there, you realize that there's a huge amount of water on the north slope we cannot characterize because it's essentially laminar flow that's underneath the vegetation. How do we characterize that? That's one of our big challenges in Alaska, and that's essentially where we're going to have to try to get a good assessment of what is the the inventory of this critical resource. Permafrost change, and that's of course happening all over Alaska. What I did not know, but should have probably, was 85% of the state in one form or another has permafrost associated with the terrains. And if you've been anywhere in Alaska, you can see where these changes take place in the upper right. As coastal erosion takes place, it can sometimes undermine or alter the permafrost. The other piece too is we see changes in the permafrost due to human activities. We've seen some of that on the North Slope. In fact, one of the challenges has been to have little or no impact on the permafrost. And actually the petroleum industry these days has been doing a very good job of doing that. We experienced that by going out to a well that was drilled a few years ago, just about 3 years ago, and knew exactly where it was by its GPS location, but because they used the ice pad on top of the tundra during the wintertime, we couldn't find the location at all. There's no sign of it at all. Earlier wells drilled back in the last part of the 20th century are completely different than that in terms of what we can see on the ground. Now, Alaska mapping, we're almost complete with acquisition here in Alaska. We're ahead of the lower 48 in acquiring the high-resolution 3D elevation model. And what that is a 1 to 24,000 scale topographic map across the entire state. Prior to this, it was at approximately 1 to 250,000. So we're seeing about a 10-to-1 increase in resolution in the system that we've got available now. What does that mean to you practically? Practically, it tells you more precisely exactly where things are located. This becomes now a reference on which you can hang everything else, which includes all that information on critical minerals. And we have an initiative inside the USGS called Earth MRI, the Minerals Resource Initiative, that's basically the ability to take all that information that you might get on the critical minerals, now hang that against the geo-instantiated information on the topographic map, and now you have information in depth. But even more critically, at the water level, if that 10-to-1 increase gives you a 10-to-1 increase in resolution gives you a 10-to-1 increase in being able to see the stream reaches. Now that's a challenge for our water resources because you now have 10 times more places that you have to characterize the water. Last thing I want to touch on here is the 21st century USGS. One of the challenges that we ran into when I first came into the job, which was just about a year ago on May 12th, is that a lot of our systems were pretty much standalone. They weren't integrated science. Now, one of the things that we do have available to us in Alaska is we have an integrated science center. Alaska has a great advantage in that it pretty much stands alone from the rest of the 48. So it can operate almost independently as far as the USGS is concerned, and that's allowed us to take our Volcano Science Center, which controls all the observatories that we have within our volcanoes hazards program, and it operates as a standalone center with an integrated science center through the water and other hazards mission areas, including earthquakes. So now all of it's tied together here in Alaska. Now what does that mean to us? We want to take that and then characterize the rest of the USGS across the rest of the country to do exactly the same thing. How does that work for us? For us, it's going to be a big challenge to try to get to where we have all of that information in an integrated form. That gets us into cloud-hosted solutions. Those cloud-hosted solutions, which we're using today, are operating at the petabyte level. We're actually heading for yottabyte level, which is going to be an interesting challenge. You can't put them in any given storage site. It's now going to have to be distributed around the cloud and instantiated against a known, which in our case is that 3D elevation model, and now you have all that information available to you. And our job in the next 10 to 20 years is to make that so you and I, as the customers, and everybody in this room is a customer of the USGS, is to make our customer-facing products readily accessible. In other words, the first thing you see is what the National Reconnaissance Office calls the Internet of Action. And that's the ability to get information that you can use as being the very first thing you see on a request. In other words, you don't have to be the person manipulating the information. We want AI and machine learning to do that for you. And so that's our big challenge over the next 10 to 20 years that we're just starting right now. First thing is integrated science. Integrated science is being done in Alaska. That's giving us a model to use for the rest of the USGS. In the next 5 to 10 years, we want to start putting that system together so that we have a truly integrated digital reference system. And then the very last piece is to get that where all of our applications are customer facing so that every single one of you in the room can pick up this thing right here that was built with the critical minerals, and you can start looking at what am I looking at when I'm driving down that road in terms of the rock in Alaska. Can't do that yet, but I promise you we'll get it there. And we're down to 4, 3, 2, 1, done. So thank you very much for the opportunity to be here with you. That was my booked time. Again, I'll be with you again in a panel this afternoon. So if you have questions or comments, please come by and see us there. Also, I'll be around, so grab me today while you get the chance. Thank you very much. So we're not expected to be on time, I just found out, which is definitely not my experience with the senator in the past. I have to tell a slight story on this one. So I go in for my confirmation hearing, and you got 5 minutes, and I think I went 6:45, something like that. So the senator, who is a great friend and a great person, as you know, very politely pointed out that we would like you to answer a few questions, Dr. Riley, and if you could briefly answer them. So right now I'm here to briefly answer a few questions while we're pulling things together here. So if you have a few, just or you have a question, fire away. This is your opportunity. Yes, sir.
When is USGS going to update, or do you plan to update the 2008 assessment you all did on the Arctic hydrocarbon?
That one is actually being completed right now. In fact, we've had the first report has already been submitted. And the interesting thing about the North Slope is, is the more we look at it, the more complex it becomes. And the more complex, though, our potentials are actually going way up in terms of what we're seeing. Back when I was a petroleum geologist back in the day, that was one of my areas as a frontier geologist, was to look at the North Slope. And at that time, we thought it was a relatively simple petroleum system. And it turns out that the sections that we didn't think had any prospective capability are now looking to be fairly significant in terms of what it can apply. So that report is now on its way out to the public. We'll have that done. And as I mentioned earlier, we're continuing with our work on the North Slope. Now, one of our big challenges is coordinating that integrated science, not only within the USGS, but also with our federal partners. One of them is Bureau of Ocean Energy Management folks and the BLM folks. And so we're tying our deliveries to their leasing schedule so that we can get a much better integrated delivery of the resource assessments. Yes, sir. Are you done? You ready? Okay. All right. Thanks again.